This is an easy question. I'll classify this one as a GMAT 600 level problem solving practice question. It's a geometry question. Concept tested properties of triangles. We'll be looking at two properties of triangles to solve this question. The first one relates to sides of a triangle, properties relating to sides of a triangle. The second one, using the properties, using the sides of a triangle, not properties, using the sides of a triangle, how does one compute the area of a triangle? We'll actually be using a formula called Heron's formula to compute the area of the triangle. Let's get started. Here is a question. What is the area of an isosceles triangle if two of its sides measure 6 and 12? What is an isosceles triangle? An isosceles triangle is a triangle in which two sides are equal and correspondingly two opposite angles will be equal. We'll restrict our focus to sides because this question deals only with sides. So we have measures of two sides 6 and 12 and we know that it is an isosceles triangle. First step, what we'll do is let's compute the third side. Right? Let's get around to doing that. First step, let's find out what is the third side of this triangle. Right? What could be the measures of the third side? We know it is an isosceles triangle. Measures of two of the sides are 6 and 12. So third side could be a 6, but the third side could be a 12. So let's look at both possibilities. Third side, if it is a 6, the three sides of the triangle will be 6, 6 and 12. 6 and 12 given. We are looking at the possibility of the third side also being a 6. Is it an isosceles triangle? Yes, two sides are equal. So that property is taken care of. Let's look at the second possibility. The third side could be a 12. In that case, the three sides of the triangle will be 6, 12 and 12. In both instances, two sides of the triangle are same. 6 and 6, 12 and 12. Obviously, if these two measures had been feasible measures, in our answer options, we would have seen two different measures for the area of the triangle. Right? Obviously, 6, 6, 12 is a different dimension triangle. 6, 12, 12 is a different dimension triangle. You cannot have the same area for that. But we saw only one answer, which points to the fact that probably one of these two is not a feasible case. What is the property of triangle that we need to use to check out which of these is feasible? Properties relating to sides of a triangle. The property reads as follows. Sum of any two sides of a triangle should be greater than the third side. The three sides are A, B and C. A plus B should be greater than C. A plus C should be greater than B. B plus C should be greater than A. But let's basically crystallize it. Let's reduce it to an easier form. If three sides of a triangle are A, B and let's take the third side as the longest side as L. This property can be reduced to A plus B should be greater than L. The rationale being that if two of the smaller numbers add up to a value which is greater than the larger number, you plug in the larger number onto the left hand side, the inequality will certainly hold good. So it's sufficient if we found out whether the two smaller sides, the sum of the two smaller sides is greater than the longest side. Let's start with triangle number 1, 6, 6 and 12. The longest side happens to be a 12. The two smaller sides are 6 and 6. 6 plus 6 compared to 12, it is not greater than 12. 6 plus 6 is equal to 12, whereas the inequality says that it should be greater than the longest side, which it is not. So 6, 6, 12 is not a feasible triangle. Let's check out whether the second one is. Second one, the three sides are 6, 12 and 12. It's the longest side. Longest side is 12. So the other two sides are 6 and 12. So 6 plus 12, is it greater than 12? 18 is greater than 12. So 6, 12 and 12 form sides of an isosceles triangle. 6, 6, 12 will not form sides of an isosceles triangle. So step 1, we wanted to find out the third side. We found out the third side. We know the three sides of the triangle right now, which are 6, 12 and 12. Step 2, let's plug this into the Heron's formula. Find out the area of the triangle. Area of the triangle using Heron's formula. I'll write down the Heron's formula to start with. Area of the triangle is equal to square root of S times S minus A times S minus B times S minus C. This is the area of the triangle. Let's get clarity on what is S, what is A, what is B, what is C. A, B and C are the sides of the triangle. In our case, we know the sides of the triangle. Basically, A, B and C would be 6, 12 and 12. What is S? S is called the semi-perimeter of the triangle. Semi-perimeter of the triangle is nothing, perimeter of the triangle is nothing but the perimeter divided by 2. Let's compute the semi-perimeter therefore. S is equal to 6 is one side, 12 and 12 are the other two sides. So 6 plus 12 is the perimeter. This divided by 2 is the semi-perimeter. 24 plus 6, 30 upon 2 is equal to 15. So you have found out the value of S. We know A, B and C. Plug it into this formula, we'll have the answer. So area is equal to square root of S, which is 15, times S minus A, which is 15 minus 6, times S minus B, which is 15 minus 12, times S minus C, which is again 15 minus 12. So this is equal to square root of 15 times 15 minus 6 is a 9, 15 minus 12 is a 3, 15 minus 12 is a 3. These two 3's will come out of the square root as a 3. 9 is a perfect square, comes out of the square root as a 3 and will be left with a 15. So area of this triangle is equal to 9 root 15. Choice C is the answer to this question. Quickly summarize it in a printed form in about half a minute so that we have clarity on what we have discussed. First step we are doing is to determine the third side of the triangle. We know it's an isosceles triangle. Two sides are 6 and 12. So third side could either be a 6 or could be a 12. Let's check out whether 6, 6, 12 is a possibility is what we said. How do we check? It needs to basically satisfy the inequality that sum of the two shorter sides is greater than the longer side. 6 plus 6 are the two shorter sides. It is not greater than 12. So this is not a feasible triangle. So done. Let's go to the second possibility. 6, 12 and 12. The longest side here is a 12. Is 6 plus 12 greater than 12? Yes, it ended up being greater than 12. So 6, 12, 12 happen to be the three sides of our triangle. Let's plug this in the Heron's formula, which is area of the triangle is S square root of S times S minus A times S minus B times S minus C. What is S? S is the semi-perimeter, which is A plus B plus C by 2. What are A, B and C? The three sides of the triangle, which in our case are 6, 12 and 12. So compute the value of S, which is equal to 15. Plug it into the formula. Find the area to be equal to 9 root 15. Choice C is the answer to this question. Hey guys, I'd really like to get your feedback about this particular set of videos. We've shifted from giving videos, making videos in the form of a screen capture into this interactive flat panel. We believe this is going to help us communicate to you effectively and make these learning videos more engaging. Love to hear from you. Feedback about how this can be made better. What would you like to see from us? What kind of questions do you want? What kind of format the teaching should be? Right? Best wishes for your GMAT preparation.